This is the demo for tweet harvesting and CouchDB utilization part of our cloud solution. And I'll start off by introducing the tweet harvesting app. And later in the video, I'll touch a little bit on the CouchDB views and the MapReduce function. And with the harvester, right now on the screen you can see two terminal windows, and on the top one right now it is right now showing the manual for our CouchDB app, and you can see we have flags for query words, location, radius, and database. You can pass in different parameters to specify your harvesting process. And at the bottom is a sample call to run the harvester, and because our topic is about the stay-home order of during the COVID-19, so we want to search all the tweets that contains words like stay home, quarantine, social distance, and COVID-19. And we'll specify the location to be Melbourne and the radius to be 50 miles within the center location of Melbourne. And lastly, we want the harvester to save all the tweets into a database called demo, just to show you that the harvesting process. We can see right now in our CouchDB there's not a demo database, but if we run the harvester and start saving into the database, and if we refresh the page, you can see there's the demo database with 48 tweets right now. And say we are running one harvester, but we later find out that there's other words that it's also about our topic, and what we can do is just run another harvester and passing different words. So in the second terminal window, you can see we want to run the harvester again with query word lockdown, coronavirus, and self-isolate. We can do that. And after running the second one, they're running side by side, all saving the tweets into the demo database. And the other side, let's look at the CouchDB. This is the old database that we previously used for saving tweets. And the problem with this is a lot of the tweets that don't contain coordinates, which is the attributes where we do care a lot about. So we can take advantage of the MapReduce function and to get a view that only contains tweets that has this coordinate column. This is our MapReduce function. This is the old database that we previously used for saving tweets. And the problem with this is a lot of the tweets that don't contain coordinates, which is the attributes where we do care a lot about. So we can take advantage of the MapReduce function and to get a view that only contains tweets that has this coordinate column. This is our MapReduce function. We do use the map function but not the reduce function, because that's not necessary for filtering out tweets that contains coordinate. And you can see under this view all of the tweets has this coordinates column not empty, which is great. Right, see, another problem that we encountered during the harvesting process is that still a great majority of the coordinates are empty for tweets. So our workaround is to reduce the radius of the request that we send to Twitter API and to make multiple requests about different coordinates. So before we send Twitter that we want all the tweets within 50 miles radius around Melbourne, but now we can say we only care about tweets that is within 1 kilometer radius around this grid, and then we move to the next grid and make a request about 1 kilometer radius around it. So this way we just send multiple search requests for each one of the coordinates in this grid. And a simplified Havershine formula is used to calculate these grids. As a result, we can replace all the null value in the coordinates in each tweet with the coordinate of in this grid that we send to the Twitter API for performing the search. Note that a hypothesis is made that the tweets returned from a query about a coordinate is from that exact coordinate location. As a result, although we receive less tweets, we can ensure that each tweet that we got has a coordinate value in it, and this ensures the greatest usability of the tweets that we have.